Hi there, everyone. Welcome to our moon video, doing the transit time of the moon. So here I have Stellarium all set up the way that I ask you to have it set up. So we've got Nashville as our choice down here. And though it does depend on where you are, on where your computer thing is. But anyways, let's use this. I've got my date and time window up in the upper left. And then I have things set up with like a star chart with south on the bottom. And then up in the right, we have the oculars and various other things, but that's what we're interested in. So let's click on the moon because that gets us our information. Note that it's near its maximum altitude, which is, and currently it's 67 degrees. But anyways, we want to focus on the moon, so let's click on oculars, and that brings us to a particular telescope. And I have it on Ocular 1. We have a generic telescope here, telescope 1, or Ocular 2, generic telescope 1, lens none. So right now, the little red moving cursors signify that we're tracking on the moon. In order to answer one of your questions, and also in order to do this method of transit times, we have to have the moon, we have to turn off the tracking. So I do that by hitting, on my Mac, I hit Command click, or you can right click with a mouse. And so now you should be able to see that the moon is starting to move. Like I've got my cursor, my mouse is not moving, but the moon itself is. So you can kind of see how the moon is moving over time. And we're about to start the method of transit times. And so you're going to have to get a timer. I'm going to pause time here, actually. I'm going to back it up just a little bit. So what I want you to do is I want you to get a timer of some kind. You can use your phone, you can use a stopwatch, you can use your own watch, whatever it is that you have, but you need a stopwatch in order to do this method of transit times. So what we're going to do is we're going to wait for the moon to start leaving the field of view of your telescope. So as if you were looking through a telescope here, and we turn off the tracking motor, and then we're going to make it, and we're going to watch it as it leaves the entire field of view. So I've let time start again. And so here you should be able to see it's nearing the edge. Here you should be about to start your timing. Ready? And start. So now we're going to watch the moon as it leaves the field of view. And the reason why it's leaving the field of view is because Earth is spinning. If you don't have your motor on your telescope tracking with Earth's spin, then you aren't able to, keep your target in your field of view. So what we're seeing right now is we're seeing the moon move out of our field of view, and we're going to utilize the fact that it takes Earth 24 hours to spin one time, which is 360 degrees. And we're going to use a conversion factor, which is given on in the lab, to determine, given how long this movement out of the field of view takes, that will end up giving us an angular size. And if we know the angular size of an object and we know the distance to that object, then we know we can use trigonometry, or well, geometry. It's a sine, or it's a tangent, by the way, if you're interested. You can figure out the actual size using just an angle. Well, sorry, it's the sine. You can use the angle, and you can use the angular, and you can use the distance in order to figure out the actual size. Now, what we're doing is we're waiting for the dark part of the moon to go off of the entire dark part of the moon to go off the edge. And you can see that there's still kind of a little bit of it there, right? So we're still kind of watching it as that dark part kind of goes off. In some ways, we have a little bit of an advantage by using Stellarium because we don't have, when we're out with the telescopes out here at Vanderbilt, then we can't see that dark part of the moon. So you have to use the light part only. Get ready to stop. You should stop it when you think you should. So I hope that you stopped it by now. So now we want to do it again because we always want to do 2 experiences with this kind of thing. And so I'm going to click on it again and get it back in the center. Going to remove the tracking, and then we're going to wait for it again in order to, so it will hit the edge again. I'm gonna scooch it just a little bit. That was not a good idea. So it's back to where it was. Okay, so you should be getting ready to have it start going off. And start it. One of the things I like about this is you can see all the different mare that are on there, that are on the moon. And it's hopefully prior to this, you've already identified the mare. Maybe you can tell which ones are which. It's kind of fun to do. And you can see all these amazing craters as well. So this is our second transit that we're waiting for to happen. So remember, we are using angle in order to figure the angular size in order to figure out the actual size. And remember, it's a conversion factor of 24 hours for Earth to spin 360 degrees. So it should work out pretty well. And you should be able to kind of just keep watching this now, and I'll be quiet up until we get to the time, about the time I'll like say something to kind of warn you that we're getting kind of close to you stopping your stopwatch. Get ready to stop your stopwatch. I'm not going to tell you when. You're going to have to stop it when you think you need to. Hopefully you've stopped by now. So we will exit out of the oculars and just kind of see our beautiful sky for right around the equinox. By the way, that was about when we had a first quarter moon, just like the one that you've been working with in class. All right, go ahead and finish the rest of the lab.